Alright, for my final video, I'm going to be working with the Winn equation. I'm going to start off with a pendulum, and then I'm going to finish off with an elastic band. Now, I'm unable to measure the spring constant of this band, so I'm going to estimate it at 0.5. So, we have our very nice pendulum here, made out of an Apple adapter that is 50 grams, as specified in my previous video, and the Apple cord. Thanks to my iPad, I'm able to do this. Now, let's imagine that this is, we could imagine this is a bungee jumper on an amusement ride, and they are swung from this pendulum into a net or band or some sort of device to stop them. Now, we need to make sure that at the speed they're going, at their final velocity here, before they push the band back, they do not break the band, because otherwise you end up with a lawsuit. So we're going to attempt to find the final velocity here using the Winn equation. Now we have this dropping from approximately 20 centimeters. Just for some visualization, that is what's going to happen with our quote-unquote bungee jumper. So, in order to solve this, we're going to have to use the Winn equation. We're going to set it up twice. First of all, we're going to find the final velocity at that point, and then we're going to find the displacement of the band. Now, we have our Winn equation written out here with the change in kinetic energy, change in potential energy, work due to friction, and change in elastic energy. Now, for our first go around, we're going to eliminate elastic because we're just working from the point where the pendulum was dropped, the bungee jumper was dropped, until right here, his or her final velocity before they hit. So, we can also get rid of the initial velocity because there was none, and we're going to say that this was at ground level, as I counted for that when I said that the jumper was dropped from 20 centimeters or 0.2 meters. So let's get rid of our final height, and we're going to get rid of friction as well. Friction is completely irrelevant here. So initial work, which is equal to 0, equals 1/2 mvf squared, final velocity squared, minus mass times gravity times initial height. Now we can simply set 1/2 mv final squared equal to mgh initial. So we can just get rid of our m's here, and we have 1/2 vf squared equals ghi. So we can plug in some numbers here, and we get 1/2 vf squared equals 9.8 times 0.2 meters, which would be equivalent to, well, then we multiply this by 1/2, or divided by 1/2, so multiply each side by 2, and you will get on the, sorry, I had to get my calculator on the right side, 2 times 2, you'd get final velocity squared equals 3.92. So the square root of 3.92 and the final velocity is equal to 1.98 meters per second. So this is the final velocity our adapter bungee dropper is going at right before they hit the elastic cord. So now we're going to set up a second Winn equation in order to find out how far back the elastic cord is pushed. Now this is going to be